Okay, so that's the formula that we've been using. I also gave it to you with the symbols when we first put it up, so I'm going to write it that way as well. And most of us are using the words though, and that's fine. What I want to point out, when we put the formula up, we talked about two issues. Okay, so we talked about the fact that students have a hard time getting the numbers on the top of the formula in the right order. That was one problem. And then the second thing that I told you to watch for was to be sure that that standard deviation that you're plugging in was the standard deviation of the population. Okay, and we said either, if you're using the symbol to make sure that you had the standard deviation of the population, or if you were just plugging it in to make sure that that's what you had. Okay, so when we look at this first problem, that standard deviation is going to be the issue that we're going to bump into, because when I look for my standard deviation in this problem, it says the sample standard deviation is 1.8. Okay, and so that is the problem that we have to deal with in this section, because the formula that we have so far requires that we have the standard deviation of the population. And we don't have that. We have the sample standard deviation. So I'm going to make ourselves a little note over here. Okay, it's an easy fix. Okay, so if we have the standard deviation of the sample, we're going to use this new table that I sent out this morning. Okay, that table at the top, it says table F for the title. The other one was table E. Right, and table F has T values instead of Z scores, or instead of Z values. And in terms of our 5-step process, that is the only thing that's going to change. Okay, and so, like I said, it's a very minimal change in the procedure. You just have to be sure that you're using the correct table. All right, so let's go ahead and see if we can start working this problem. So remember that we said that when we write the hypotheses that we are looking for words like greater than, or less than, or increase, or decrease, right? Those are the keywords that we would be looking for. So do we see any of those keywords in this problem? More, less, greater than, less than, increase, decrease, anything like that? Okay, so if I don't see anything like that, what do you say?
I say it's average.
Right, so if I don't see anything like that, okay, so I know that the null has an equal to regardless, so that's really not up for discussion. But the H1 now, what's it going to look like? If I don't have anything as a keyword, what am I going to use here? The equal sign with the line through it. Good. The not equal to. So that's sort of your default if you don't have a keyword that indicates a greater than or a less than. Okay, and then what number do we want to use? 16.3. All right, and I'm coming right from that first sentence where it says a medical investigation claims. Okay, so we'll need that just a minute. Claims that the average number of infections is 16.3. All right, so which one do I write the word claim by? Which one? Okay, so the H1 says that it's not equal to 16.3. I think that this is saying that it is. A medical investigation claims that the average is 16.3. So I'm going to put the word claim by the first one. Okay, does that make sense? Now, most of the time, we do have the claim by the H1, but it doesn't have to be there. So this one says the claim is that it is 16.3, so that means equal to. All right, everybody okay with that part? All right, so step 2, how do we shade if it has a not equal to in the H1?
You shade both sides, right?
Good, you shade both sides, yep. Shade both sides. Okay, now this is the step where we use the other table. Okay, so normally we could go to our original table and look up these critical values. Now we're going to be using this new table, right, to look up the critical values. And this is where we see a change in the process. Okay, so let's take a look at this table for a second. All right, so across the top, you have a row that says one tail and two tail. We're going to be using those two rows only. Okay, so we will not use the top row where it says confidence intervals. So either the one tail or the two tail, depending on what your picture looks like. Okay, so our picture that we just drew was two tail. Good. All right, and I also need my alpha values. Let me go back and look real quick. All right, so we said alpha was 0.05, right? Okay, two tail 0.05. All right, so two tail 0.05 is here. Okay. All right, down the side, you see a DF. Okay, so DF is your sample size minus 1. Okay. There's a reason. I'm not going to explain to you the reason why it's that way, but that's just the way that this table works for us. Sample size minus 1 is what we're going to look up down the side. So our sample size for this problem was 10, right? So we are going to look up 9. Remember, sample size minus 1. So we're going to look up 9. All right, and so I'm going to go across. And I'm going to go down. All right, and we're looking at 2.262. Sorry. All right, does that make sense? Anybody have a question on the table? Okay, so let's go put it on the problem. 2.262. So right here, then we have a negative 1 over here. And then that is the only change in this process. Okay, so everything else from this point on is going to work exactly like a problem in 6.2 or 8.2. Okay. All right, so I'm gonna go get my formula. Now, when I use my formula, I probably don't want to say z is equal to, but the actual formula doesn't change. Yeah, we'll say t is equal to, but the formula is exactly the same. So no change there. All right, so what goes on the top? Let's think about the order of the top part of this thing. Okay, which one comes first? Good, 17.7 comes first. Okay, and again, the easiest way I'm going to tell you to check this is remember that the number over here in your hypothesis should be the second number in your formula. Right, so that's the best way I'm going to say, make sure you got them in the right order. Okay, standard deviation was 1.8. Sample size was 10, right? All right, and then we're going to take that to our calculator. And we're going to plug it in. Did you get Taylor? 2.46. Yep, that looks good to me, 2.46. Okay, anybody have a question there? Okay, so let's mark it off on the curve. So 2.46 is going to be over here in the shaded region. Remember that you're comparing it back to 0. There's still a little bit of a back and forth with some of you guys about how do you know whether to reject or not reject. All right, so the question that you're really asking yourself is those two blue marks that I just made, are they the same or are they different? And I would say that they are different because they are far enough apart that I'm concerned about it. Like if I wasn't in the shaded region, if I was somewhere over in here, I would be saying, yeah, they're basically the same number. But as soon as I cross that dividing line, they become different. The null hypothesis says that they're the same because it says that they're equal. So basically, I'm looking at this saying to myself, I don't agree with the null hypothesis. I say they're different. The null hypothesis says they're the same. So what am I going to do in step 4? I'm going to reject. Okay, any questions there? All right, and then the last step, we'll go to our table. I'll go back and see if I can find the table. All right, so we said that the claim was H0, and we're going to reject. Go. All right, so the claim is H0. We said we were going to reject. All right, so there is enough evidence to reject the claim. Should be what you write for part E. There is enough evidence to reject the claim. That the average number of infections. Our claim is if it's equal to 16.3, so it is 16.3. right, anything there that you have a question on? Let's view at home, anything you need to ask? That's here, okay? So again, just kind of keeping it summed up for you, the only difference between this section and the last section was that part number 2, where you're going to the table. So you either go to the first table or the second table, depending on that standard deviation.
So when it says sample, we could use table F.
Yes. Right, yeah, go ahead, Jason.
So how do we know which table to use? I know I was probably here if you said that.
Yeah, let's sum it up right here. Okay, so I'm just gonna write it up here. So if you have the standard deviation of the population, you're using the first table, which was table E, and it's Z values. All right, and if you have the standard deviation of the sample, you're using this new table, which is table F, and it's T values. Again, the only step in the process that really impacts is where you do your curve and you find that critical value. Everything else is the same. So in most cases, you'll see that the problems will actually tell you. They'll say sample standard deviation, or they'll say population standard deviation, which makes it easy for you to decide which one to use. Sometimes they don't. So this one is one where they don't, and I wanted you to see this so you can kind of know what to do with a problem where it's not specifically stating sample or population. We'll give you a minute to finish writing things down. Okay, so from this point on, what I would suggest that you do is that you find the standard deviation in the problem. Okay, because that really needs to be the first decision that you make, is which table you're going to use so that you know how to proceed with the problem. So I'm going to key in on this part right here first. What you need to decide, if they don't explicitly tell you sample or population, you need to decide which one it is. So if you'll read that entire sentence, then I think that we'll be able to determine where they got that standard deviation from. So that sentence says a sample of 15 joggers had a mean of 40.6 and a standard deviation of 6. So basically, they took the 15 joggers and they calculated the mean and the standard deviation, right? Okay, so that 6 that they calculated comes from that sample. Right, so that is the sample standard deviation. Which forces us then to use the new table, right? All right, so what I want you to do for me, I'm gonna let you kind of work on this one for a few minutes. So let's do the hypotheses and then let's check and make sure that we're on the right track with the hypotheses. Okay, so see if you can find a keyword, see if you can write those two statements. I'll give you just a minute to see if you can do that part. All right, so did you find a keyword? What was it? Greater. Okay, so we're definitely gonna have a greater than like that. All right, what number are we using? It just says greater than the average of all adults. So what, 36.7 is the average of all adults. Okay. And what about the claim? He claims that it's greater, right? Okay, so I'm gonna write the claim next to the greater than one. Okay, everybody okay with that? Okay, so go ahead and keep working. All right, so step 2, you're gonna use your new table and determine your critical value, and then go ahead and do your formula. I'm just gonna give you a few minutes to work on this one, and then we'll check. Okay, so let's kind of see where we're at. Does everybody agree that we shade on the right because it's a greater than?
Yes, yes.
Okay. So it's one tail, it's 0.05, sample size is 15. All right, so let's go back to our chart. One tail, 0.05, and then 14 down the side, right? Because remember, it's one less than your sample size. Okay. So if your sample size is 15, you're going to 14.
Good.
All right, so we should be at 1.761. Okay, 761. Okay, formula, what goes where? So let's see the T. Right, so 40.6 minus 36.7. 6 on the bottom. Square root of 15. Good. What'd you get? 2.52. All right, anybody got a question up to that point? All right, so let's mark it off. All right, so 2.52 is going to sit over here in the shaded part. Carrying it back to 0, where's the other mean is? You're asking yourself, are those basically the same or are they different, those two marks? They are different, right? They're far enough apart that I'm going to be concerned about whether it's okay or not. Like this part, if it was in here, it might just be like a rounding error or maybe a sampling error, but it's not enough of a difference to get worried about, right? When we cross the dividing line, this is far enough apart that we're going to go tell somebody that they were wrong. Okay, so these two values are different. So we reject. Good. And remember, the null always says they're the same. Okay, so we don't agree, so we say reject the null. All right, and then the last step is to go get your chart, your little table. It tells you what to say for the conclusions. That. All right, so on this one, we had that the claim was H1. And we said that we were going to reject it. So we're writing this. There is enough evidence to support the claim. Got the average. Oxygen. The claim was that it was greater than 36.7. All right, any questions or problems there? Okay, so the last thing I want to show you, and I'm not sure that we have time that we're going to get all the way through it, but I want to show you one of the problems where they give you the data. We saw some of those in the last section where we had to do some calculations. You're going to see more of that in this section, all right? And I want to be sure that we're okay with how to handle those numbers. Okay, so if you want to take a picture of that one, this will be our last problem. So when we did these problems in the last section, we had to calculate the mean. All right, in this section, they're also going to be asking us to calculate the standard deviation. So we're going to need to find both of those things. Now, let's see what it says. An educator claims that the average salary of substitute teachers is less than $60 a day. Okay, and then it says we have a random sample of 8 school districts. Okay, so this is your sample right here. So know that anything that we calculate with those numbers is going to be a sample statistic. When we calculate the mean, it's the sample mean. When we calculate the standard deviation, it's the sample standard deviation. Okay, so I know right now that I'm going to be using the new table to work this problem. What I want to be sure of is that you guys remember how to do those calculations. All right, so the mean is fairly easy, right? How do we kind of find the mean of something?
Yeah, I need to divide that.
Okay, good. Add them all up and divide by however many you have. So that shouldn't be too big of a deal. Okay, so I'm going to add these things up real quick. All right, it's going to give me 471. I have 8 numbers, right? And so that's going to give me 58, if I do 2 decimal places, 58.88. Okay, now the standard deviation is a little bit more involved. So you've got a couple of choices here. We've learned how to do it by hand. Your calculator, if you have a TI 83 or 84, will also do it very easily for you. Okay, so if you have the right calculator, I would suggest that we do it on the calculator because it's faster and easier. If you don't have one of those 2 calculators, you are going to need to review how to do it by hand so that you can get the number that you need to work the problem. So I'm going to review it by hand with you, and then I have a video that I'm going to send out later today that goes through the calculator part with you. I can try to show you guys here in class. Okay, so you will have a video. It would be difficult to show you right now because I can't show you a calculator as we're doing it. So I just did a quick video on finding that standard deviation, and I'll send that out. Okay, but for right now, let me just kind of remind you the by hand part. All right, so remember that when we did it by hand, we took our numbers and we put it in column 4. And we added them up. Okay, so we've already done that. We already know that that's added up to 471. So that was part of it. And then remember that we went through and we squared each of those numbers and we added that up. So we did like 60 times 60, and that gave me 3,600. And 56 times 56. 3136. And 55 times 55. 3025. 70 times 70. A lot of these are repeats. Okay, and then I added those up. Step. Go to calculate. And then more. Four times. So that's the mean we just found. And then this is S for standard deviation. So that's the second. To calculate. And then four times. So that's the mean we just found. Standard deviation. I'll still send the video so you can have the steps. All right, so remember our formula is the bigger sum minus the smaller one squared. Okay, we divide by the number of values, so we have 8. And then on the bottom, we do 1 less. So we put 7 on the bottom. And this is actually going to give you the variance. Okay, so let me do that real quick for you. So that gives me 25.84. And then remember your standard deviation, you have to take the square root of that. So we get 5.08. Right, so again, my preference would be use your calculator if you have the ability to do that. Okay, so if you have an 83 or an 84, definitely watch the video that's going to come out today so that you can put it in your calculator and do it. Okay, if you don't, then just kind of review those steps so that you're able to calculate that standard deviation. Right, does anybody have a question on the calculation? Okay, so real quick, let's just get started on the problem. Like I said, we won't finish. We only have a couple of minutes. So when I go to write my hypotheses, do you see a keyword? Less than. All right, so we want a less than in this one, and it's less than what? What number? 60. Good. All right, and that first sentence says the educator claims that it's less than 60. So I'm going to put the claim next to that. All right, so for step 2, if it's less than, we know that we're going to shade on the left. All right, and I'm going to go to my new table, and I'm going to try to find that t-score that goes with it. So 1 tail, 0.10, and 7 down the side. 1.415
or negative.
negative. All right. Formula. So I know the 60 goes on the back side because that's the one in the hypothesis. So the one we calculated, 58.88, goes first. Standard deviation, we said 5.08. And sample was 8. Good. Okay. So I get negative 0.62. All right, and let's just get it marked off and then we'll stop there. So negative 0.62 is going to sit pretty close to 0 here. So I'm looking at those saying those are basically the same. Right. Null says that they're the same, so we say do not reject the null. All right, and I'll stop there.